right, so I'm gonna be completely honest here. It's a new day. This is a huge job. It's a multi-day thing. So we let the engine basically continue to drip overnight onto some stuff that we laid on the floor, cardboard, whatever. No matter how long you let this sit, it's gonna continue to drain oil. First thing we're gonna do, we need to remove the oil pickup tube here for the engine oil pump. On this engine, there's two pumps. There's a high pressure pump for the Vanos system, which I'm not even gonna refer to as an oil pump. It's basically a hydraulic pump because it runs at several hundred bar of pressure. The low pressure pump right here is what supplies engine oil to the entire engine. So this is gonna lubricate everything up top and everything else. So we're gonna remove this first. We have some T30 screws up here. I'm just gonna remove those. And we got another T30 there and then a 10 mil back here. So we're gonna do the 10 mil next. And we also have a T30 up in here we're gonna remove. I have an oil catch directly below the low pressure pump because I expect once I pull this pickup tube out, it's just gonna purge oil everywhere. I'm gonna finish removing the T30s up here now. And then from here, we can just pull the pickup tube out. And here comes more oil, as predicted. All right, now we're gonna work on removing the low pressure oil pump. The low pressure oil pump is chain driven off of the high pressure oil pump. You have this lower guide rail, and then there's a tensioner up top. First, we need to remove this guide here bottom. We don't actually need to completely remove it. We just need to remove this T30 screw right here, and then this whole thing will kind of pivot down and out of the way. That'll just kind of stay on the high pressure oil pump. At the moment, we're not replacing either one of these pumps. We don't suspect that there's any problems here. So, but yeah, as you can see, that just kind of slides down out of the way. And that gives us a little bit of slack here on this chain. Next, we're gonna take a 16 millimeter socket and remove this nut that holds the sprocket to our low pressure pump. And this is just a normal threaded nut. Should come off fairly easily. There we go. Broke free very easy. A lot of BMW oil pump nuts are reverse threaded, but because of how this is driven on this, it's just a normal right hand thread nut. And now we can pull the sprocket off. It just comes off like so. We'll leave the chain hanging. We're gonna inspect this sprocket closer once we get it cleaned. Yeah, I mean, normally these are not gonna be replaced, but if there is damage on it, like any kind of wear on the teeth, we're gonna take care of it. We'll look at this closer once we have it all out. Now we have these two 6mm bolts in the front here. We'll remove these. These physically mount the oil pump to the engine block. And I know what you're thinking, that socket does not look like an Allen, but I promise you it is. It's a special type of Allen socket that will prevent any rounding. So the last thing you want to do on this job is round any of these cap bolts off. Now removing the low pressure pump is required to remove the high pressure pump, and removing the high pressure pump is required to replace the Vanos line. And also having these pumps out of the way is going to make it much easier to replace the rod bearings for cylinders 1 and 2. And then this is the third mounting bolt for the oil pump. I'm gonna hold on to it as I remove this bolt, and I do expect even more oil to come out. Make sure you have a good grip on the oil pump as you pull it out here. We're gonna take a look at this pump on the bench after we clean it up, make sure everything is good. Have seen instances where the casing has cracked on these for whatever reason. Same thing with the high pressure pump, we're gonna inspect that as well. And right here, this is actually the little hydraulic tensioner for that chain. So when we pull our high pressure pump for the Vanos, we're gonna make sure that this valve doesn't fall, hit the floor, pieces go everywhere. It's 3 pieces. There's a spring, there's a little hydraulic valve, and then there's the actual follower there as well. So we're gonna be careful when we pull that apart. Before we move our high pressure pump, we're going to remove the banjo bolt here. This is for the high pressure Vanos line. 17 millimeter. So we have 3 10mm bolts that holds the high pressure pump to the engine block. I'm gonna go ahead and remove those now. And there's one more 10mm over here on the front corner. Here's our little tensioner that I was talking about earlier, trying to avoid having it fall out. Unfortunately, it did. This little orifice valve actually stayed up inside the block. So it's these 3 pieces. Make sure you put these off to the side and make sure you have all 3 pieces. This little orifice valve limits the amount of oil that comes into this tensioner. So you want to make sure that you have this when you go to reinstall everything. The only thing we really need to do at this point, obviously our Vanos line is nice and loose. We do have a in-block oil filter here, which is for the high pressure pump. We need to remove this because we will be replacing it. We're just gonna go ahead and pull this out. So it's just basically a little screen to make sure that any big debris doesn't get into the high pressure pump and cause other problems. It's very important that this gets replaced during this job. Right here, this is the oil feed for the high pressure oil pump. This physically feeds the pump itself. This is the high pressure Vanos line that goes up to the fitting or the junction at the top of the engine block. Here's the gear on the crank that physically drives the high pressure oil pump. Because it's gear driven, when we reinstall this, we're gonna have to set backlash. There's a specific number you're supposed to be at or a range, but you can actually see with the right viewing angle exactly where that high pressure oil line goes up to the top of the engine block. Unfortunately, because of the design of it, the only way to physically replace this line is to remove the high pressure oil pump. There's no way to wiggle this out, and because of the backlash setting, you're always gonna have to adjust backlash when you reinstall this. So there's 6 13mm bolts that hold this cover to the front of this harmonic balancer. Behind this cover are 4 E-Torque screws, which is actually what physically mounts the harmonic balancer to the crank shaft. We're going to use those 4 bolts to bar the engine over by hand, because what we need to do is for each set of rod bearings we're replacing, those 2 connecting rods need to be at bottom dead center for easy access and room to work with. But we'll be using a special tool from BMW that allows you to use the head of the E-Torque bolts to bar the engine over by hand. Here's the special tool from BMW we're going to be using to manually turn the crankshaft. Like I said, there's 4 E-Torque bolts that hold the harmonic balancer to the crankshaft. So it's not like there's like a centrally located bolt you can just move by hand. So this is the special tool that BMW has. Works for S54s, S65, and S85 engines. We're always going to want to move the engine in the correct rotation, so it's always going to be spinning clockwise when we're facing the front. So here are the 4 E-Torque bolts we're telling you about. This special tool just kind of sits on those 4 bolts. It's 1/2-inch drive. And then what we can do is physically move the engine with a ratchet. And I'm gonna get cylinders number 1 and 2 to bottom dead center. And we'll start the connecting rod bearing replacements on cylinders 1 and 2. So I'm just looking for those connecting rods to come down to the bottom where we have access to the bolts. And right there looks good. I'm gonna take a silver Sharpie here. I'm gonna mark a side of the connecting rod. And the reason for this is I wanna make sure that when I put the bottom half back together, that those markings are on the same side. These are fracture split rods, and we'll show you what that is in a minute, but I wanna be able to visually see which side needs to go where as I do this. Our connecting rod bolts are 12mm 12 points, so we're gonna go ahead and break those free. I'm gonna do each side a little bit at a time. And then once they're free, they'll actually come out pretty easily. I'm gonna use the 2 connecting rod bolts to put some pressure to get it off. And you can see right there what I mean by fracture split. You can see how those mating surfaces there are completely uneven. When these connecting rods are manufactured, they're cast as one piece, and then they have a machine that literally splits these. So each one of these is unique, and you need to make sure that the cap goes back onto the exact same connecting rod. If you don't do that, you're gonna have a lot of problems. So for us to keep track of this, again, marking the side of the connecting rod that goes to the upper portion of it, and we're gonna be doing one at a time. One thing that you need to know about this rod bearing service on any of these S85 or even the S65 engine, BMW has updated the rod bearing since the original design. One of the biggest changes is the metal that's being used in the bearings. For example, lead was a very common material that was used in bearings, but because of new laws regarding the use of lead in automotive applications, particularly wear applications, heavy metals are not really a thing anymore. So BMW's updated these rod bearings. What we're going to be installing today is the new mixture. We'll tell you exactly what the specifics on this bearing are in the description. But I did want to show you the rod bearings that came out. So this is cylinder number 1. Here's our bearing from the bottom portion of our connecting rod. A little bit of wear, nothing too crazy. But then when we look at our loaded side, so this is physically the piston moving down onto the crank journal, you could start to see that there's a lot more wear that's happening here. Generally speaking, you're always going to see more wear on the loaded side, so this is physically what is pushing down on top of the crankshaft. But there's nothing here that is too wild. It did go through what looks to be the top layer here, but it hasn't gone any deeper than that. Before we took this off, I did make sure that all of the connecting rods didn't have any excessive play in them. Of course, there's a little bit side-to-side play, there needs to be, but there's nothing, like there's no radial play up and down on it that I can detect, so I don't think we're gonna run into anything on this that's too wild or out of control. This car only has 60,000 miles on it. I can definitely tell you it's not had the best oil service regimen done. This is the oil that we drained out of the engine yesterday. It's very black. I would suspect that this car has probably only seen 3 oil changes in its entire life. And I would say, realistically, depending on the condition of that oil, poor oil is going to cause lubrication issues, which could cause additional wear to occur. I think another thing to note with these engines, there is a rev limiter when the engine is colder, and that rev limiter is progressive as the engine temperature comes up. The worst thing that I think you do in these engines is let it warm up at idle. Number one, it's going to take forever for 10 liters of 10W60 to come up to temperature at idle. But what you really need to do is start the car, let the idle come back down, and just drive it gently until the engine comes up to temperature. That's going to be the best way to make sure that oil is being circulated in the engine, that's come up to temperature, and realistically, it can help reduce a lot of this wear. But either way, these rod bearings are a wear item on these engines. It just is what it is. So at 60,000 miles, I think we're kind of getting ahead on this one. And we'll get this taken care of today, and hopefully it goes more than 60,000 miles without needing it the next time. But first thing I'm gonna do is clean our connecting rod bolts. I've had these soaking in oil for most of the day. They do need to be installed oiled, but I wanted to let any surface coating, any kind of dirt, dust, kind of fall off in the oil there. Use a little bit of brake parts cleaner on them, get the additional oil off, and then when we go to install our new rod bolts, they'll be fresh and ready to go. Of course, I'll put oil back on the threads. That is what BMW wants you to do per TIS. So using some lint-free shop rags here, just drying them up a little bit. And what we are doing today is we're using factory connecting rod bearings, and we're using factory connecting rod bolts. There's a lot of options on the market. There's coated bearings, which honestly the new connecting rod bearings are in fact coated from the factory. There's also ARP fasteners, a whole bunch of different type of connecting rod fasteners that you could use, but we're just choosing to use the factory equipment today. Obviously the choice is up to you, whether you want coated bearings or factory bearings or extra oil clearance bearings. That is all up to you when you're doing the service. One thing to be extremely careful with when you're doing this job is which information to rely upon. If you look at the BMW ETK parts diagram, it gives you the inverse information of which color-coded bearing should be top and which one should be bottom. Never rely on a parts diagram to tell you the orientation of what bearing goes where. It's general information, it's only parts information. What you want to rely on is the TIS instructions. In this case, the blue color-coded bearing is going to go on the top portion of the connecting rod, and the red coated connecting rod bearing is going to go on the bottom half. Make sure you install these in the correct orientation. It is done for a specific reason. It all has to do with clearancing. So whatever you do, make sure you follow the TIS instructions for this repair. Do not rely on the parts diagram to tell you which bearings go where. All right, so I made sure that our connecting rod is nice and clean and dry. And as you can see, the new connecting rod bearings, they have tangs on both top and bottom. The tang is what secures the connecting rod bearing into the crankshaft. When you talk about spun rod bearings, it's because the rod bearing has wore down so badly that the tang is literally worn off. And basically at that point, there's nothing retaining the connecting rod bearing inside the connecting rod, and it literally just spins and destroys everything. So these are brand new. When you insert them, you're gonna go tang in first, and then you just kind of push them into place. And again, red on the bottom and blue on the top. It's important to use assembly lube. You want to pre-lubricate the bearing because once you restart the car, it's going to take a couple of seconds for oil to make it through the oil pump, through the crankshaft. You can see the oiling holes. That is what creates the cushion of oil that the rod bearings ride on. So before that happens, you want to make sure that there is something pre-lubricating this so that damage cannot occur. So we're going to use this LM48 installation paste. It is ideal for this application. I'm just going to put a nice thin coating. You don't need to put a ton on here. It doesn't need to be swimming in the LM48. And I recommend using your fingers, wear rubber gloves, clean rubber gloves. So you can just wipe your hand clean, and then you can also go ahead and install the upper connecting rod bearing, which in this case is going to be blue. That goes into the upper connecting rod. And again, you want to make sure the connecting rod is dry, clean, etc. All right, let's go install this upper bearing onto the connecting rod. So we disconnected the lower portion of the connecting rod bearing. We actually pushed the connecting rod up so that we can physically get it into position. Again, this is a blue bearing for the top, and you want to get this seated in the tang, which is your first step. And then once it's seated, you just want to push it so that it seats into the connecting rod, like so. And I'm just going to lower it down so I can get a better look at it. So it's really important that you make sure that you get this thing properly seated. All right, so now I'm just going to take a little bit of our assembly lube and put it on this upper bearing shell. And now we'll pull the connecting rod down onto the crank journal. Now I'll just pull it down, like so. Then we're going to take some engine oil and lubricate our connecting rod bolts. We're going to line up the bottom portion of our connecting rod. Thread our connecting rod bolt in, get it started. Lubricating the threads as well as the head of the bolt. And we're going to go ahead and draw down the connecting rod evenly. So I'm just spinning the bolts by hand. Here comes our torquing sequence. It's 11 steps in total. 6 Newton meters, then 20 Newton meters, and then 130 degrees of rotation. We're going to back the bolts off. We're going to follow those torque steps again, back the bolts off, and do it one more time, a final time. So this is our 6 Newton meter joining torque. And then I'm going to go to our next, which is 20 Newton meters. This is our setting torque. And now we're going to come here to our angle, which is 130 degrees. And now we're going to go ahead and break it free again. Setting torque, 6 Newton meters. 20 Newton meters. Now 130 degrees. Breaking free again. Joining torque, 6 Newton meters again. 20 Newton meters. And 130 degrees, our final torque. All right, we just did connecting rod number 1. Everything that we've just done, we're gonna repeat 9 more times. All the way down the line, so now I'm gonna go to cylinder number 2, move the engine over, we'll move to 3, 4, 5, 6, 7, 8, 9, 10. So far through this repair, all of the connecting rod bearing wear has been pretty consistent. A couple of the connecting rod bearings we're starting to see a little bit of copper showing through, but nothing horrific, nothing awful that you would typically see posted on a forum somewhere. Again, 60,000 mile engine, so we're doing this early. One thing we haven't done so far through this is we haven't done a clearance check on the axial play for the connecting rod bearings. We're going to be using a MPG-1 plastic gauge. This is what BMW recommends when you're doing this job as a quick check. You know, there is a range here that you're allowed. In this case, on the metric scale, we're looking at 27 thousandths to 76 thousandths, which is pretty wide, but that is what BMW has listed in the TIS. So we're going to go with that. Again, this is a green plastic gauge. We're going to go ahead and smush it. We will be reusing the original connecting rod bolts that came off this particular connecting rod because you are allowed to reuse them to do clearance checks. You don't need to waste new bolts on that. One thing when you do this, you want to make sure that the connecting rod journal is clean. You want to make sure there's no oil on it. This does need to stick to the connecting rod journal for it to technically be accurate. So already did that, installed both new upper and lower bearings. So we're going to go ahead and do a quick check. Make sure that everything is where it needs to be. I'm pretty sure it's going to be fine based on what we see so far. One thing I've been doing through this is if I'm having a hard time pulling the connecting rod back down, I'll just thread in a bolt, and that makes it a little bit easier, especially when the valves are closed, because all you're really doing is just pulling vacuum, which makes it harder to pull it down. You have the plastic gauge installed on the bearing. Now, just push it up. We're using the original bolts from this connecting rod, so they've already been pre-stretched, but that's fine for this measurement. You don't need to use new bolts or waste new bolts for this. So we'll do the joining torque of 6 Newton meters, the set torque of 20, and then torque angle to 130, and then we'll remove the cap and we'll use our plastic gauge to measure to make sure that we are within spec, which, seeing as there's not really any optional bearings in terms of clearance here, it's either within the range or it's not. And in this case, we're at 51 thousandth, which is dead nuts in the middle. So no problem here whatsoever. Everything works out really nicely. So now that we got all of the connecting rod bearings replaced, next up we need to remove the Vanos high pressure line, which is one of the things that we need to do to take care of this. To be honest with you, one way or the other, if you need to replace the Vanos line or you need to replace the connecting rod bearings on this engine, you should also be replacing either or, just as preventative. So I'm gonna have to move the either pulley out of the way here. Just gonna pop the cap off with this pick. And then it's gonna be a 16 millimeter bolt. I'm gonna remove this bolt, 16 millimeter. This will also allow us to get the belt out of the way, because currently it is in the way. I'm also gonna remove the water pump pulley. BMW says you need to remove the power steering pump slightly. I'm actually looking to avoid that altogether. So I'm gonna see if I can sneak this out without having to undo the power steering pump pulley, or power steering pump itself. Just breaking these 10 millimeter screws free. That torqued very tight, so you can really do this by hand. I'm using just a tiny ratchet. Again, this is to get better access to the banjo bolt for the Vanos line. Pulley just came off easily, which is always nice. Now I got a pretty good line of sight on the Vanos banjo fitting. Hoping that there's just enough vertical room to sneak the hose out. Looks like we should be able to do it. All right, the banjo bolt is a 19 millimeter. Now, there's definitely no pressure in this line. so I don't have to worry about oil going everywhere. However, I'm going to put a rag down there to catch any potential backflow. There's a bracket on the water pump pulley. You can see it right here. This is for the high pressure Vanos line. However, this line goes down to the pressure accumulator. It also comes up here to the junction or the T at the top that splits off between the two Vanos units. So if you remove those 10 millimeter screws, because we haven't had enough 10 millimeters, we should be able to get enough wiggle room that I can pull that line out of the way, get access to the 10 millimeter on top, holding the high pressure Vanos line to the block, and we should be in business to pull that line. We're gonna break these 10 millimeters free, and then we'll have enough line, or we'll have enough slack here in this area to move the main pressure line and the accumulator line out of the way. Don't want to bend this line, whatever you do, so just remove this bracket that's bolted to the water pump. I'm already starting to see some wiggle room here for this junction line that goes to the high pressure Vanos hose that's internal to the engine. I can see it's moving, which is good. To hold the power steering pump pulley, I just use the power steering pump belt. It's a nice little cheap trick just in case you need to counter hold it. What will happen on these pulleys is the pulley shaft will corrode. It'll pinch the plastic pulley, and then it'll make the pulley an absolute nightmare to remove. So what you have to do is work it back and forth. You can use some penetrant fluid to try to help break up some of the rust. You can see it's starting to move. All the power steering pump bolts are 13 millimeter. Just breaking these free. A little bit difficult to see. The cooling hoses are kind of obscuring it a little bit, but just kind of feeling for where they are. And once we have these bolts out of the way, should be able to slide the power steering pump forward, and then we'll be able to move the Vanos pressure accumulator line forward from behind the harmonic balancer, and then we should be able to remove the Vanos feed line inside of the engine. I can visibly see that the power steering pump is loose, so I should be able to pull it forward slightly to give myself the room. Now we have to remove the 10 millimeter bolt that holds the Vanos line to the top of the engine block right there. Have enough room, wiggle room, with the preformed Vanos line up here that I should be able to get this 10 millimeter set screw out. And then I'm gonna have to figure out how to pull this Vanos line up and out of the engine. All right, that 10 millimeter screw is loose. I mean, you can kind of see what I did with those lines. I kind of just pushed everything in front of the harmonic balancer. When I put this back together, I'm gonna have to make sure everything goes back behind. But now we should be ready to pull this pressure line. I'm gonna give the line a push from underneath the car. There's an O-ring that seals it, so I wanna make sure that it pops free the O-ring, and then I should be able to pull it up the top of the engine. So we have that line loose from the access point on the timing cover there. You want to pull out between the radiator hoses and the cylinder head. So you're going to pull it straight up. I'm just using this pick to kind of bring it up to my fingers. I'm going to keep pulling it straight up. And now we're going to hit a point where there's some resistance. There's a bend in the line, so we're going to rotate it now that we have it high enough, and the whole thing will just come right out. Here's our old Vanos line that's been pulled out. We do need to do some preparation work before we install the new high pressure Vanos line. As you can see, it does not come with the sealing O-ring. The sealing O-ring, of course, which was difficult to remove. So that is purchased separately. It comes with a kit. I'm gonna go ahead and slide this O-ring onto our new line here. This O-ring just simply seals the line to the engine block. So it is important that this is replaced, because if it's not, oil will leak out of that area. So we're just gonna slide the O-ring on. And then I have a little bit of engine oil here. I'm just gonna go ahead and lubricate this O-ring. Since it's gonna be exposed to oil, I'm gonna use the oil for lubricant, and now we're gonna go ahead and drop the new line in place. Okay, now we're gonna install our new line. Gravity is gonna work with us on this one, fortunately. So we just need to work the line until it just kind of starts falling into place. And now I just need to orient it so that that tab with the little hole for the 10 millimeters facing forward, but the hard part is done. It's down inside the hole. Once the bent portion of the line was down into the block, I had to spin it back around 180 degrees. Once I was able to bring it around 100 degrees, it pretty much just dropped into place. From there, that O-ring fitting is pretty tight. So I used a long screwdriver to come down between the cylinder head and the radiator hoses. And I was able to push down on it until that O-ring went in, sit nice and flush in there. Now I'm gonna reinstall the set screw that keeps this in place. This is our banjo bolt. This is for the fitting on top of the engine block where it tees off. We're using brand new crush washers. We are reusing the banjo bolt. There's nothing wrong with it, so there's no reason to replace it. There's no clogging, anything like that. The tricky thing here is going to be sliding this washer underneath while I put this in. Before you tighten the banjo fitting down, you need to make sure that accessories are kind of back and the routing is where it needs to be. All right, I'm going to mount the power steering pump back into where it belongs. I don't need it out of the way anymore, so I'm gonna slowly start drawing these bolts down. I don't wanna get them too tight and then put another one in a bind. And you know, if you're doing this and you feel any kind of pressure whatsoever on any of the bolts, stop, because you're not lined up. All right, they're all engaged, so I can actually go ahead and commit to tighten it down. Torque spec on these 3 mounting bolts is 21 Newton meters. I'm gonna take a 17 millimeter socket. I'm gonna draw our banjo bolt down, but I'm not gonna tighten it. I am gonna torque it. 25 Newton meters of torque is the spec. I just wanna get the bolt down and bottomed out before we go ahead and torque it. Torque spec for the banjo fitting is 25 Newton meters, 17 millimeter drive. This is gonna be the last thing you do. This is after you get the power steering pump realigned and bolted back in, and you get that bracket at the top of the water pump secured. Here is our high pressure oil line that we just installed, and before we reinstall or begin to reinstall the high pressure oil pump, we need to install a new screen in block. This is the feed for the high pressure pump. Installation is pretty easy, just goes up and in. No specific orientation, just push it up and it should go flush to the block. Before we reinstall our high pressure pump, we need to also put this tensioner back in. There's no way to do it if the high pressure pump is in there. Put a little bit of oil on the little tensioner piston there, hoping the oil will create enough suction that'll just kind of keep it in place for us. Also going to put a little bit of oil on the little orifice valve. As you can kind of see there, the little valve should be pointing downward into the spring, and then spring, then this little piston right here. All right, now sliding the high pressure pump into place. A couple dowels it needs to line up on. Go ahead and put these screws in. I'm going to do it loosely. One thing I want to do is make sure that I put the pump back to a pretty close place to where it was originally when it was removed. That should keep us from having to make too many adjustments. Go ahead and draw these screws down a little bit here. I'm not trying to make them super tight, I'm just trying to bottom out the pump against the engine block. All right, so we have our dial gauge set up on the high pressure oil pump. Unfortunately, there is a special tool to mount the dial indicator base to the engine block. We didn't get this in time, so we've had to resort to different measures here. Found a piece of scrap steel that I was able to drill 2 holes into to mount to the bottom of the engine block, and now I have the magnetic base of the dial indicator on that. The key is you want the dial indicator to point vertical from the bottom of the sprocket here. And the adjustment range you're allowed to have is anywhere from 0.06 millimeters to 0.08 millimeters. Right now, if I go from stop to stop on this, I have anywhere between, we'll call it 0.09 to 0.1. So I'm gonna have to actually remove some backlash. So I'm going to tap the oil pump towards the crankshaft. Using a rubber mallet, you're allowed to do this. These bolts are tight, but they're not torqued, so we have a little bit of side-to-side adjustment here. So I'm just gonna give it one little tap and see where we end up. That might have been too much. Actually, we're at we're between 0.05 and 0.06. So really close. Really, I mean, ideally you wanna be at 0.07, dead in the middle. So let me just hit it one more time on this side. As gentle as I could be with it. And right there, we're at 0.07 millimeters of backlash. I'm going to zero it one more time. We're going to have 0.07 millimeters of backlash, and now that that has been adjusted, we can go ahead and torque the oil pump down to the engine block and then move on from here. All right, we're now going to torque the 3 mounting bolts to 10 Newton meters, 10 millimeter drive. Next up, we're going to install the banjo bolt into the high pressure pump. This is the line that we installed earlier. Torque spec on this banjo bolt is 25 Newton meters, just like the top. Now we're going to take our low pressure pump, put it up into location. There's no gaskets or anything, it just goes directly to the block, so we want to make sure that it's on the dowels first. And I'm going to take our longer bolt, thread that in first, just to kind of hold the pump in place. There's no special alignment or anything that we need to do for this. All I'm gonna have to do is put the sprocket back on the pump, lay the chain over the sprocket, bolt this lower guide back on, and once that's done, we do have to make one quick measurement to make sure that the adjustment of the chain tensioner is within spec, but I'm not worried about that. There isn't really any wear here. It wasn't even worth replacing these guides because honestly, they're in really good shape. Torque spec on our oil pump mount bolts is 20 Newton meters. And from here, I'm going to slide the oil pump sprocket back over the shaft. This is a little bit of a finicky process. You want to make sure that it gets on the splines, and this should usually go in place like so. 100% make sure the oil pump does land on the splines though. And from here, I'm going to take a little bit of red Loctite, put it on those threads, and then this nut is right hand thread. Now we're putting the lower chain guide into place. This is a T30 screw. We will go ahead and torque that. 10 Newton meters. Worth noting, there's two different style oil pumps. This is the serrated shaft style oil pump, so it has the serrations that the gear sits on. The other version's dihedron style. Torque spec on the serrated is 25, torque spec on the dihedron style is 50 Newton meters. But we'll be doing 25 because this is serrated. Just doing a quick measurement on the chain, make sure that there's enough tension. So from the edge of the lower guide rail to the top of the chain, that's 73.54 millimeters. You're allowed anywhere from 72 to 80 millimeters in this measurement. So more than enough there. We don't have to, again, there was never a problem to begin with. Just double checking, it's part of the TIS instruction. We're good to go on that. So now we're gonna go ahead and put our oil pickup tube back on. We go ahead and install a new O-ring on our oil pickup tube. We're just reusing the original one. There's nothing wrong with it. You could replace it if you wanted to. And now we're going to insert it in the back of the pump. You want to make sure that it is fully seated into the back of the pump. Should be a fairly tight seal. Definitely lubricating the O-ring will help get it to go into place. But you'll feel the O-ring pretty much pop into place. We're going to reinstall our T30 screws. We have another T30 in the back here. And then we have a 10 millimeter here in the rear. Just a normal 10 millimeter 6-point. One thing to note when mounting the oil pump pickup, there's 3 T30s, one 10 millimeter, 10 millimeters in the rear, and then there's a T30 with a washer that goes here, and then the 2 T30s without a washer come up here to the oil pump. So just make sure you're aware of that. Torque in all of the strainer or oil pump pickup bolts to 10 Newton meters.